In question 6, the first three terms of an arithmetic progression are p square upon 6, 2p minus 6, and p. Given that the common difference is not 0, we have to find the value of p. Now, in an arithmetic progression, we know that the difference between two consecutive terms is equal. So as we have the first three terms, we can say that the second term, which is 2p minus 6, minus the first term, which is p square upon 6, will be equal to the difference of third and the second term. So we can write it as p minus 2p minus 6. Taking the LCM on the left hand side, we'll get 12p minus 36 minus p squared upon 6. And opening the bracket over here, we'll get p minus 2p plus 6. So p minus 2p will be minus p plus 6. And we'll multiply this by 6. So this will be 6 times minus p plus 6 is equals to 12p minus 36 minus p squared. Simplifying this, it will become minus 6p plus 36. And we'll bring the terms on the left hand side to the right hand side to make it positive. So we can write it as plus p squared minus 12p plus 36, and we'll have it equal to 0. We'll rearrange the equation to write it as p squared, and minus 6p minus 12p will be minus 18p plus 36, and plus 36 will make it plus 72 equals to 0. Factorizing this, we'll get two values of p as p equals to 6 and p equals to 12. Now, as the question said that we have to find just one value of p, we'll substitute both of the values of p to see which one to use. So let's say if you're using the common difference for the third term and the second term, which is p minus 2p minus 6. If we use the value of p, which is 6 minus, so 2 times 6 will be 12 minus 6. So 6 minus 6 will be equals to 0, which means that we cannot take this value of p as it is giving a common difference of 0. And the question has already said that the common difference is not 0. Just to confirm, if I substitute instead of 6 over here, if I substitute 12, so this will become 12 minus 24 minus 6. So this will be 12 minus 18. So as the common difference is not a 0, it means that the value of p that we'll use is p equals to 12. Now in part B, it is saying that using this value, find the sum to infinity of a geometric progression with the first two terms p square upon 6 and 2p minus 6. Now the formula for sum to infinity is a upon 1 minus r. So the first term is p squared upon 6, which is equals to a. We will be using the value of p, which is 12. So this will be 12 squared upon 6. So 144 divided by 6 will be 24. And to find the common ratio, we will divide the second term, which is 2p minus 6, by the first term, which is, well, we already have the first term, that is 24. So the common ratio will be 2 into 12 minus 6 divided by 24, which will be 24 minus 6, 18 upon 24, and we can write it as 3 upon 4. And now we'll just substitute the values of a and r into the formula for sum to infinity. So that will become 24 divided by 1 minus 3 upon 4. Substituting this in the calculator, the sum to infinity we'll get is 96.